talk about how to normalize our database design. Normalization means it's nothing but the segmentation. So for what? To remove the redundant information. We cannot actually make the redundant free database design. That doesn't make sense. But if we have a lot of redundant information, it's very hard to manage and also hard to find a certain data. So we try to remove such a redundant information. How can we do that? If we follow our traditional database design, such as that consists of the conceptual design and physical level design. Sometimes it works, but sometimes it may have such a redundant problem. So how can we define such a redundancy using the functional dependency? If we can find a set of attributes determine another set of attributes that can be considered as the redundancy. As we have discussed in the informal guideline, so the best way of the database design in terms of the informal guideline is one table, one entity, one relation, indicate one meaning. Okay, that makes sense. Then avoid any anomaly and as less as null as possible. So that is the informal guideline. To make the formalized such a the problem, so we first define the functional dependency. So functional dependency means a set of the attribute determine the other set of attribute. But how many functional dependency for each relation? There are many. It's limited, but so many different functional dependency you can find. So we limit such a functional dependency as the minimal functional dependency. So there are rules, the inference rule. Using the inference rule, we can actually define the minimal functional dependency. However, intuitively, you can understand what is the minimal functional dependency. That is the core part of the functional dependency. So from now on, we consider the functional dependency as the minimal functional dependency. In other words, if we take out any of the attribute from the functional dependency, that's the totally different meaning. Okay? So when we find the minimal functional dependencies, so using such a minimal functional dependency, as well as the prime attribute. What is the prime attribute in case of the functional dependency? Left-hand side will be considered the prime attribute. That determines the other. So the other attributes are considered as the non-prime attribute. So we are interested in such a prime attribute determine non-prime attribute. So the normalization process is we try to decompose. Whenever we find any problem, like the redundancy problem or the database design, how can we solve the problem? It's a decomposition, segmentation. We can segment. So somebody can imagine, I got a couple of times this question. What is the best ideal case of the database design in terms of functional dependency?
Having just
one attribute for each table. That is the best in terms of, there might be no redundancy, right? Because each table has only single attribute. However, that is not good for managing. That is not good for accessing the data. You need to access sometimes. Think about your SQL or relational algebra. How many attributes you are going to access from the same table? Sometimes asterisk, all attribute, right? So to access the data using such a single attribute table, you need to join a lot of tables. Then decrease the performance. That is not so good. We try to make them group. Okay? So that is the normalization. So normalization form starts from the first normal form, second normal form, third normal form. I don't discuss about the denormalization. That's one of the topics today. Okay, so we will set aside the denormalization. So to understand such a normalization process, so we try to understand the concept of superkey. Superkey is any left-hand side that determines the right-hand side. So that is a superkey. So how many superkey? There are so many superkey, just like so many functional dependencies. Okay. Super key can be social security number plus any attribute that can determine another. But we are not very interested in the super key. Instead, we need the key. Key is the minimal super key. As if we define the minimal functional dependency. So that is the definition of the key that we have used in the ER modeling, conceptual modeling. So there are many keys possible. So among them, we will select one of them as the primary key. The other will be considered as the candidate key. So both attributes from the both primary key and secondary key, they are considered as the prime attribute. Because this prime attribute will determine non-prime attribute. So using this definition, the first normal form focus on only attribute by attribute. Okay, we are not interested yet the relation or table yet. Focus on the attribute. So no composite, no multi-value, no nested. You can understand why no composite, no multi-value, no nested. Because it's a single value, right? Relational database model, clearly mentioned that it's a single value attribute for each the column. Okay, single value. So they are not single value. We are not going to allow it. This is an example of the. It's an unnormalization. It's not normalized. It's just the back of the information. Okay, because this one has the multi-valued one here. This one has the multi. However, this one is the first normal form. Even though there are a lot of redundant information, we focus on only attribute. So nested also is not part of the first normal form. That is the reason relational database model cannot handle object-oriented model. Okay, object-oriented model, due to the nature of the object-oriented concept, so a lot of the inheritance, a lot of nested. It's a very easy concept, but not in relational database model. That's the main difference between the relational database model and object-oriented model. In other words, if you want to make the build object-oriented database, you need to consider such an object-oriented concept model as the data structure. So at that time, probably each attribute, each table, each the entity can be considered as nothing but object. Okay, so they can sometimes inherit each other. So these kind of problem will be easily addressed in object-oriented model. Okay, then you can easily work with the object-oriented language. Okay, from the database. Unfortunately, this is not in our real situation. That causes a lot of problems. But I probably mentioned the couple of times, due to the power of current DBMS vendor, it's not easy to change. But probably it will be eventually changing. Okay, so next is second normal form. In the second normal form, we focus on the prime attribute. So ideally, all prime attribute, all key determine the other non-prime attribute. That makes sense, right? If there exists any partial dependency, that is a different meaning. So second normal form does not allow the partial dependency, only whole key dependency. Okay? So for example, social security number, P number determines something. However, if a social security number determines employee, P number determines project, that's the different meaning. So that is not in second normal form. How can you address the second normal form? How can you make the second normal form? The only solution is a decomposition. You can take out that partial dependency part. For example, here you can see the three functional dependency. When I'm saying the functional dependency, that means the minimal functional dependency. You can find as many functional dependency as possible here. Social security number plus e-name determine variable. Social security number, P number plus hours plus e-name determine hours. There can be also functional dependency, but we are not going to consider all functional dependency, only minimal functional dependency. In this case, there are three minimal functional dependencies. So one is social security number plus P number determine hours. The social security number determine e-name. the P number determine P name and P location. There exists partial dependency, even two partial dependencies. Okay? So, what is the solution? How can we make the second normal form? Decomposition, segmentation. You can take out this part, partial dependency part, like the social security number determine E name, P number determine P name and P location. Why don't you think about the informal guideline? The first informal guideline is 1 minute for each table. 1 minute, 1 minute, 1 minute. There are 3 minutes in this. Okay? This is the second normalization. In other words, I have a question. What if the prime attribute is just one prime attribute? It's already second normal. Why? It cannot be partial. Right? So many of the cases when you have the single attribute for the primary case, automatically second normal form already. So in case the partial. Okay. The next one is the third normal form. Third normal form happen in this case. What about not this one? In this case, it's a single prime attribute. It's automatically second normal form. You don't have to worry about this much. What about the third normal form? So social security number determine B date, address, E name, and D number. And D number determine D name and D manager social security number. This is also so second normal form. However, you can realize that this is for D number, this is the department, this is the employee. That may be happen because we have this one determine this one determine this one. It's called the transitive. So if we believe that this is kind of redundant information, how can you solve the problem? It's a segmentation. We can take out this part, and the D number will be the prime attribute, the primary key of the new table. So this is called third normalization form. So good news is, if you believe you are a normal person, even though you do not have any knowledge in computer science, even though you do not have the idea of the normalization form, anybody can design up to third normal form, because that is the nature of the human thinking process. So if somebody asks, why don't you organize your room, probably you will put all the stuff of the database, and this is the operating system. You don't want to mix stuff, right? So that is the nature of the human thinking process. So human thinking process actually can do up to the third normalization form. And also, this third normalization form is the most of the case, almost 95% of the database design is a third normal form, which means you can easily do the database design. That is the reason without taking this course in your programming class, in your software engineering class, probably many of you guys already use the database. At that time, even though your instructor never taught you how to design, how to normalize, you create the customer table, and employee table, and item table, transaction table, because it's already third normalization. Okay? The problem, bad news is, the other 5%, they may cause the serious problem. So, for example, when I design and implement everything, so I launch my system. It works very well at the beginning, but a year later or 2 years later, eventually your system will be degraded. Also, you can find a lot of redundant information from the database. You may realize later. Then at that time, if you want to separate, it's really hard. Why? Because if you change the database design, you need to change all application and all the interface. So it will be very hard if you realize such a problem later. So you'd better check mostly up to BCNF. The next, what is the BCNF? This is a quick summary of the first normal form, second normal form, third normal form. So key depends. So it's a single attribute. And whole key, not partial. And nothing but the key. In case of D name, it's not key, but it's a determinant. So BCNF means, so what about this case? Is this the first normal form? What is the first normal form? You should be able to understand this one. Definitely, this is the exam question. Who knows? There will be pop-up quiz. So is this the first normal form?
Yes.
Check the attribute by attribute. Single, 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 single. It's okay. It's the first normal form. Second normal form.
Yes.
What is the second normal form? Whole dependency, no partial. For the prime, what is the prime attribute in this relation? Be careful definition of the prime attribute. Whole attribute of key. That include candidate key. So this is also, even though it's not underlined. Why? Because only one primary key. But it's also key, candidate key. So this attribute belongs to the candidate key is a prime attribute. So in this case we have the three. Property ID, country name, and last number. This is the prime attribute. Then, whether this is a whole dependency or partial dependency. This is the what? Whole dependency automatically because it's a single attribute key. What about this one? So country name plus lot number determine area, price, tax rate. However, country name determine tax rate. This is a partial dependency. For what? This candidate. Okay? Is this the second normal form or not? It's not second normal form yet. Because of the functional dependencies 3. This is a partial dependency of candidate. So what will be the solution? Segmentation. We can take out the functional dependencies 3. And why don't you think about the informal guideline? This is the country name. Each country has their own tax rate. Custom tax rate. That makes sense, right? That is the different meaning comparing to the other. Okay, so we can take out this one. So this is the second normal form. What about the third normal form? What is the third normal form? No transitive. Not, it will be determined by only prime attribute. However, we can see the area determine price. That is a transitive. Okay? So this is not in third normal form. What will be the solution? We can take out the area determine price. So this is the third normalization form. Okay? Yes.
How would you know the candidate keys?
In this case, it's given. Okay? So you need to find it when you design. So you can find from ER modeling. If ER modeling allow no primaries, no key. Sometimes multiple keys. Okay? Based on your design, you may have the candidate key. Okay?
But for
In
example,
this case, it's given.
in the exam, you will give us like this.
Yes.
Okay.
Otherwise, it's only underline the primary. Right? So this is a third normal form. So we will imagine one more functional dependency. Suppose that area determine country name. That makes sense, like the East Asia, okay, Middle East, Europe, North America. It's area, okay. So area determine country name. Is this the third normal form or not? Third normal form, okay. The right hand side. This is actually right hand side. Left hand side determine right hand side, okay. The area determine country name. At that time, transitive, in case of transitive, the third normal form, this is not a prime attribute. Okay? So this is okay in terms of the transitive. Why don't you think about the A determine B? So A is the prime. B determine A again. Okay? It's the same meaning. Right? Strongly it's the same meaning. However, if you consider this one is also transitive, okay, then we can take out that part, the area determine country name, cause, if you allow this one, we will see the example. It may cause something the redundant. It's actually not the really redundant information, but it may cause something complicated the information to understand. So we can take if we consider this one as the transitive, that is called BCNF. So how can we solve the problem? We can even take out the area, determine the country name. So in my case, this is the best way to understand. Sometimes it's hard to figure it out whether this is the BCNF or not, pseudo-transitive or not. It's fine. A, B determine C, and C determine B. There is no case actually like this one. A, B determine B, B determine A. There is no case. However, this kind of the composite primary key determined by the partial. A, B determine C, C determine B or A. That is the typical case of the BCN. Okay? At the time, if we consider this is a redundant information, then we need to solve the segment. That part, that is the BCNF. So BCNF is a more strong case. Okay? It depends on the application and database design, or sometimes project manager or ask you need to have the database design up to BCNF level, or the third, the normalization form. In general, small case, the third normal form is okay, but in real, the system is up to BCNF. So this is the case of the BCNF. So you can see, you don't have to worry about too much meaning of that, but student, course, instructor. You can see some redundant information, right? Database, the taught by the mark, database taught by the mark. But anyway, student plus course has the determine the instructor, right? But instructor determine the database because of the email has the redundant information. What will be the solution? Is also segmentation, but there are options. Okay, there are many cases to segment this problem. Like for example, it can be segmented as a student, course determine instructor, and instructor determine course. Okay, or the student, instructor, and student course. The instructor determine course, and the course is instructor, and so on. Depends on what, where you are focusing on. Okay, for example, here, students are most of the table relation. Okay, then student and instructor, student and course. Here, you are interested in the course. Course are both of them. Then instructor determine course, and course and student is the primary. Here is an instructor. So, however, none of them actually purely redundant free. Why? Because the student information here, student information here. The course information here, course information also here. Instructor here, instructor here. Okay? You cannot actually solve the problem of the BCNF in terms of the redundancy. But we try our best depending on where we are focusing on. So that is the BCNF, and the functional dependency and normalization process. Definitely, normalization process require your practice. Okay, so I think when is the due date of the quiz normalization? Today?
No,
Thursday? Why don't you try to do your best to solve the problem? I know that's not easy. So on Thursday, the GA will explain the couple of cases example at the beginning of the lecture regarding to the normalization. Okay, before that, why don't you practice by yourself and bring. If you have any question, bring your question and ask either the GA and me. Okay? Any question? Yes. Yes.
First question.
So the quiz, you have to print out the quiz and do it here?
I know. Quiz is you just like the previous one. You can submit it online. But so your homework. But on Thursday, the beginning of class, the GA will explain a couple of questions, not all of them. But if you have any question, you can ask a question during the lecture.
Okay, second.
Yes.
In the quiz,
Uh-huh.
it's basically on the 3 forms. The first, second, and third.
Yes, it's the mention. You need to do the up to the BCNF or third normal.
Oh, so BCNF will be included.
Yes, some of them. Not all the time. You can find the BCNF.
Okay.
Sometimes.
And third question.
Mhm.
The office hours before class, right?
Yes.
Okay, maybe that's it.
And fourth question.
Good question.
My office hour is not after class.
Okay.
Okay. So, any other question? Any other question? Okay. So we are going to quickly move to the next topic. So far we have focused on design. Okay? So do you remember that the doing schema architecture, NC standard database architecture? So top level, then start from the lower level. It's the internal level and conceptual level and external level. What we have focused on where? Conceptual level design. Okay? Who is in charge of the internal level? DBMS. So that is the reason we actually, I think that was the question, your midterm exam, right? So who is in charge of the internal level? Have we discussed about how to organize the file detail? Yes, we have a little bit, but mostly who developed, who used such an internal level structure? Oracle database, MySQL database, and the DB2 database vendor. They should know. Because of that, we don't have to worry about. Which means when I submit the create table employee with a column name, then you don't know how the employee table will be created, where the table is created. Do you think that is good? That's kind of abstraction. You know what is abstract? Abstract, you hide inside. Nowadays, most of the concept in computer science is abstraction, like the object-oriented concept. Benefit? You don't have to worry about that, what's going on inside. Instead, you can use the method, okay, or the something operation to use to access, to manipulate the data. Problem? You don't know really how it works, how the database query is accessed and where your data is located. So in terms of the administrator, you should be able to know do you know what is the most frequently asked question when I was the database administrator? The database is slow. Most of the user, most of the developer, they complain. They never complain their query is slow. Whenever they encounter the problem, it's slow, or the no response, they complain the database system is slow. Something wrong. Sometimes yes, but most of the time no. System is okay. Then, how can we solve the problem? Just return, ignore. So, we need to do something that is called tuning. Okay, we need to tune. Like you are interested to tune up your car. Do you drive? No, not yet. So probably some of the people are very interested to tune up your car or to tune up the electronic device. So what is a tune up? You can enhance the performance. Similarly, database require a lot of the tune-up process, tuning. So there are mainly two types of the tuning. First one is system tuning. So if your database system itself is really slow, we need to do something. Change the configuration, change the parameter value, assign the fast device. There are many factors, so we cannot discuss more such all the thing. Okay, just the understand what is the system tuning and how we can do that. Another part of the tuning is it's a SQL tuning. When developer asks, the system is slow, first take a look at whether query itself is correct or not. Okay? So to do such a, sometimes by changing the order of the table in the from clause, select from where, by changing the order, performance will be totally different. Sometimes it takes several days, but exactly same query, but the different order, it can be 2 or 3 seconds, really. That may happen. So that is called the SQL tuning. So most of the time, database administrator can be tuning both the SQL and the system, but nowadays there are the third-party company or the independent consultant who are in charge of such a tuning process. You can easily imagine how much they are paid. It's a lot. So they usually work the contract, based on the contract, 2 or 3 days. If they can increase 20% of the overall performance, then they got paid more, something like that. So huge a lot. But so you should have something sometimes the intuitive approach. You don't know why you cannot explain, but you can start from the memory tuning or something parameter. So sometimes it's very hard to explain. But here we will just overview of such a database tuning and the practical database design. Then, what will be the basis of such the practical database design and tuning? It will be based on always, I think I emphasize on a lot the importance of this one in the database design at the beginning of this class. When you design the database, you need to understand customer request, customer requirement, as well as application analysis. Sometimes how can we determine when we have the 2 candidates, which one will be better? It depends on, right? Then you can just say that depends on, you need to decide one of them. At that time, you need to take a look at your application part. So analyzing, when you tune up or design the physical database, you need to understand the query and transaction. So, for example, for each query, you need to collect many information. For example, which file will be accessed. Eventually, your table will be stored at the file, okay, or certain location. That, for example, Oracle database used something DBF file, and SQL Server used a specific file name, and each DBMS used their own file structure. So you need to understand which file will be accessed. Why? Because eventually, physically operating system, in terms of operating system, certain file will be accessed. So you need to change the location if the file is accessed a lot. Okay? And also, probably when you are doing the phase 2 of your project B, what is the most difficult part? You need to understand your query itself. At that time, you need to segment the input query by table name. Right? Also, you need to segment your input query by attribute in your where clause. Which attribute are used in select condition, where clause. Right? Why? Because that will be the key. That will be the main part when a query optimizer determines which table will be accessed first, which index, whether primary key will be used, whether the secondary index will be accessed. At that time, you need to, it's the same thing. Here, when you design the physical level design of the database, you should know the attribute. And how often they are joined, how often they are retrieved or updated. It's a similar thing. For each update, you need to do the same thing, and basic idea of so this I/O is the main, the cost to determine the efficiency of your database system, right? So as we have done in the query optimizer, how can we measure the cost of the query? Number of I/O. So I/O is the most expensive, the operation. So our goal is distribute such an I/O as much as possible. And we can. So after analyzing such a query or the operation in your data in your database system, your goal is to distribute the I/O. Then how can you distribute the I/O? This is the most frequently happen. First, when you access the data, how can you access the data? Index, then table, right? Which means, in one query, when we access the data in the table, how can we access? Through the index. Which means, what if? Which one will be better? We have two hard disk drive, so index is here. Table here. Table, index. Which one will be better? One or two? Definitely, one is better. One. This is kind of the room and door. Okay? This is a door and two room and two door. So first access the index, then let DBMS know where the data is located, get the data. On the other hand, in this case, you need to access this, you need to access this. It's kind of bottleneck. Okay? It can be bottleneck when you access the data. So this one is the distributed. So if index table has the index, you'd better separate index and table. Does it make sense? Why? To distribute the I/O. The problem is, so I have a laptop, I installed the Oracle database, so Professor Lee suggests, why don't you distribute the index and the table. So I create the, for example, folder, D drive, I create the two volume, E drive. So D drive has the index, E drive has table. Can you get the benefit of the performance like this? Actually, no. Logical volume does not have. Instead, this disk, when you distribute the I/O, it's a physically distributed, which means it's a disk controller. This one should have the disk controller. Okay, then this one is connected to the bus. So it should be distributed physically. Then you can get the benefit of distribute of the I/O. Also, sometimes table okay? For example, this table is the employee and customer. For example, it's the customer, employee, customer. Customer. This is a transaction. They are accessed together usually. So customer do something to the transaction. At that time, you'd better separate such a way. Also, transaction is usually what? It's kind of history, log data. And customer is not much changes a lot. Okay? How many banking customer a day? How many transactions? Huge. So you need to consider such a thing, and you can save the different media to separate, to distribute the I/O. So when you design the database physically, the logically you have done so far. Then I'd like to create the database. If you do not specify such a location, it will be stored at what? Default. Each DBMS has the default location. So you don't have to worry about that. But the problem is it will be created in the same database location. So you can specify the different location. Okay? So our goal of the physical database design is to distribute the I/O. That is our goal. How can we do that? By analyzing the frequency of the query and branches. And the others are the same, almost the same problem. So I will quickly skip. So when you design, you can consider the index, each index attribute, and each one will be cluster index and hash index, dynamic hashing. But anyway, this is for indexing. Regarding to the indexing, so most of the time when a user, developer, asks the system is slow, then they suggest, why don't you create the index? Creating index sometimes can be solution, but not always. Why? Why the creating index is not always the solution to tune up the SQL? When you create the index, what happens? Storage. It needs the storage, and also I/O. It requires I/O. So we have the employee table. So this one has the default primary key index. If I create the index, the attribute A index, it has the storage. Also, it requires I/O. Also, you need to sort the data. What if there is a new data inserted? You need to sort the data. You need to sort the whole index. If you have the 10 indexes, you need to update the 10 indexes. Okay? So it may degrade your overall performance. Okay? So because of that, also if your database design is correct and ideal, actually primary key index is the best way to access the data. If you need a lot of the index like this way, then maybe not always, maybe the designing problem you need to think about redesign your table. Okay. So that is the thing you can consider for when you design the index. Okay. The next one is the denormalization. What does that mean? Denormalization. Normalization means segmentation. So denormalization means desegmentation, which means put together, merge. That's it. Then Professor Lee said the database guys, database really hate the redundant information. When you merge two tables like the employee and department, it will be redundant information. Then why we need to consider denormalization? Fast. Yes, correct. How can you make denormalize the table fast? Why the denormalization is faster than normalized one? Access. Instead of accessing two tables, you can access only one table. So it's a trade-off. If you believe the performance is really, really critical, you can merge two tables. Then you can easily access. The problem you need to manage manually the consistency of the database. It may cause a lot of anomaly, but you sacrifice that part to get what? Speed. But if you believe the speed is okay, so at the time you can normalize. That is the normal process. So denormalization is a special case. After you normalize everything, but you encounter speed problem, efficiency problem, at that time you can denormalize the table. Let's see the example. Do you think it's normalized? We have employee ID, project ID, employee name, employee job title, percent assigned, project name, project manager ID, project manager name. It's from here. What about the first normal form? Probably yes. Okay. We are not sure exactly, but so probably it's a single value. What about the second normal form? Employee ID and project ID will be probably primary, right? Here, employee ID determines this one. Employee ID determines this one, and project ID determines name, ID, manager name. Employee ID plus project ID determines percent underbar assigned, right? So for example, employee ID 111 and project ID A 10%, 111 40%, 111 C 50%, something like that. Okay, this is the example of this one. Then it's not in second normal form. How can we make the second normal form? We can take out the employee ID. We can take out the project ID. Then we can have the employee ID, project ID plus percent time, percent underbar assigned. Then we can make the second normal form. That is the full dependency. Then when you analyze the pattern, when you analyze the database query application program, okay, you realize that most of 99% of such a query and application program access employee name, project name, and percent of assigned. Yes. But if you separate the employee table and project table and assignment table, you need to join. Select from employee, project, and assignment. You need to join 3 tables every time. So as I said, join is one of the expensive operation. As you have seen in the query optimizer, we need to find the access, how to access this table, how to join this one, and also how to join this one. Right? So depending on that, it will be definitely slow. So what if we combine, put together this into this? Then when you access the query, you don't have to worry about the join. So that is called denormalization process. So denormalization, after you normalize everything, in case the performance efficiency is critical, and most of the case there is you access all together at the time limitedly, not always. So limitedly you can allow denormalization. So that is called the denormalization. So what is the goal of the denormalization? Why do you need to consider the denormalization? It's a performance, it's a speed, it's an efficiency. That is the only reason. So you should not use a lot for such a denormalization. Why? You may lose some important information like the employee. If you have a lot of application or query, that access only employee, that access only the project, you'd better keep the normalized. Okay? So you can normalize such a thing, but if you join all together, you don't have to do that. Okay, so our goal of the tuning we already discussed so fast. What is the main reason you use the database system? You are taking the database course. Why do do you need the database?
To get data.
To get data, you can get the data from
Yeah.
memory, from the file, without using database. If we do not have the database, you don't have to take this course, right? You can enjoy your life. Why do we need to consider the database? Why do you need in your computer science or IT project, and why? Manage the data. Protect the data. There are many reasons in chapter 1 and 2, but in mine, this is my personal opinion, not general opinion. In my personal opinion, the first reason why we consider database system is efficiency, to access the data very fast. Okay? If your data, if you want to manage the data or security, so you can use a file system, you can use a memory-based system, whatever. But the main reason is how to speed up. So to keep